Hello everyone, and welcome to our introductory unit. For our unit, we chose to teach chemical reactions. We're going to begin today with a little overview of the unit, and then we're going to go on to do a bit of review on atoms and molecules, which would be considered lesson 1. Lesson 2 is going to be writing and balancing chemical equations, and the chemical equations we're going to start balancing are synthesis and decomposition reactions, which is going to be found in lesson 2. Lesson 3 will tell us about single displacement reactions and double displacement reactions, and lesson 4 will be our final lesson on combustion reactions. So like I mentioned, today is going to be a quick review on atoms and molecules, and we're going to start by talking about the difference between the two. As a quick review from grade 9, since this course is tailored more towards the grade 10 course, atoms are single elements on the periodic table, or single units of elements on the periodic table. So for instance, a single atom of sodium, or a single atom of potassium, or a single atom of magnesium, all separate, are atoms. Molecules, however, are combinations of atoms. So a molecule would be something like H2O, which is water, composed of 2 hydrogen atoms and 1 oxygen atom. NaCl, sodium chloride, is table salt, and that would be composed of 1 sodium atom and 1 chlorine atom. Finally, something like calcium oxide would be composed of 1 calcium atom and 1 oxygen atom. So to continue our review, we're going to start talking about how to count atoms. Just like we did with these molecules, different molecules can be counted in terms of the number of atoms that make up the molecule. So the first one we looked at here was H2O. The subscript 2 applies only to the H, and since the O has no subscript, it's implied that it's a 1. So in total we would have 2 times H atoms and 1 times oxygen atoms in 1 molecule of H2O. As a second example, let's look at something like iron oxide, Fe2O3. At any point, you can feel free to pause the video and try the questions yourself, but I'm going to go ahead and do this one. The 2 represents the number of irons, since it's the subscript of iron, Fe, and the 3 represents the number of oxygens, O. So in total, there would be 2 Fe's and 3 oxygens. So 1 molecule of Fe2O3 is composed of 2 iron atoms and 3 oxygen atoms. So let's try one more difficult example of counting atoms. And then we'll go on to talk about how to name atoms, or how to represent the composition of atoms from the chemical name. So the last example we should try here is an atom that contains a molecule that contains more than just one type of atom, or more than 2 types of atoms, I should say, like the other one. So here we only had hydrogen and oxygen. Here we only had iron and oxygen. Here we're going to have 3 separate elements: calcium, oxygen, and hydrogen. And this is a new notation that we haven't seen in the last 2, where there's a subscript applied to a whole bracket. When we have these brackets, that means that everything in the bracket, the subscript applies to everything in the bracket. So here, this would be called calcium hydroxide, because this is called the hydroxide ion, OH minus. And there's 2 hydroxide ions in this compound, each of which contains 1 hydrogen and 1 oxygen. So if we write the chemical composition of this, or the atom composition, there's 1 times calcium right here, because the subscript of calcium is not there, implying that it's a 1, like before. And here, there's 2 O's, and there are 2 H's, because both of them are in the bracket with the subscript 2. So 2 times oxygens, and 1 times hydrogens. Sorry, 2 times hydrogens. My mistake. So the hydrogens, there's 2 hydrogens, just as there's 2 oxygens. Both of them are in the bracket. So now we're going to talk about how we actually name these compounds. All of these compounds, I've been stating the name and writing the formula, but I haven't really explained how I'm getting to this point. So the first thing you need to know about naming compounds is that the metals on the left side have positive charges. So on the left side of the periodic table, you have your alkaline earth metals, which have a +1 charge. So for example, sodium and lithium are examples of alkaline earth metals on the left side of the periodic table that have a +1 charge. And next to them are the alkali metals, and those are things like magnesium and calcium that have a +2 charge. So when we try to name a compound, for instance, sodium chloride, like before, which is composed of, as we mentioned, Na, 1 sodium atom and 1 chlorine atom. When we made this chemical composition, if we were to convert this from the name sodium chloride, then we would have to know that the charge on sodium is +1. Non-metals on the right side of the periodic table, you can find their charge in the opposite way, and they have negative charges, such as chlorine or oxygen. And chlorine has a -1 charge. I'll give you the charges now, but you can review the folder that we have that reviews all of the grade 9 unit, and it will show you how to find the charges of metals and non-metals from the periodic table. But from the charges, we crisscross them down through what's known as the crisscross rule to figure out the subscripts of the metal and the non-metal in the compound. So in this case, there's going to be 1 Na and 1 Cl, and as we mentioned before, there's no need to write 1s because they're implied if it's not written, so we just call this NaCl, as we mentioned before. Let's try another example. Let's try magnesium iodide. So as I mentioned, magnesium is part of the alkali metals, which all have a charge of +2. Iodide happens to fall in the same column as Cl on the periodic table, which all happen to have a charge of -1. To figure out the compound that this is going to make, we crisscross the charge of iodine down and the charge of magnesium down to the subscript of iodine, and we get Mg1I2. As always, the 1s are implied, so this becomes Mg I2. Now the last kind of example we should do is one that involves the multiple, more than 2 elements in a single compound. So for this one, we're going to try something called calcium nitrate. Whenever the suffix of the second part of the chemical ends in 8, that implies that there's more than just 2 types of atoms. Instead, there are going to be 3 types of atoms. So in this case, the third type of atom is always going to be oxygen. Just like in the previous example with the hydroxide, it was OH, calcium nitrate. The nitrate ion has 3 oxygens on a nitrogen with a total charge of -1. When we write the compound name, we again write calcium with its +2 charge, but now we write the whole nitrate ion together with its total charge. And we again apply the crisscross rule. But now it's important to remember that we need the brackets around the NO3 to represent that the whole ion is being doubled. So as a final review from before, let's count the atoms in calcium nitrate. Because the subscript of calcium is just not apparent, it's implied that it's a 1, so there's 1 calcium atom. Because all of the nitrate ion is inside the bracket, there are 2 times 1 nitrogen atom and 2 times the 3 oxygen atoms that are all in the bracket. So it's a total of 6 oxygen atoms. And that summarizes our review of grade 9 material. What we're going to be moving on to, as mentioned before, is the actual chemical reactions. And we're going to be starting in our next lesson with synthesis reactions. And I will be showing you there how to balance chemical reactions as well. Thanks for tuning in, and we'll catch you guys next time.